Algebra 1. Variables and expressions. A variable is a letter or symbol that represents a value that can change, i.e., x or t. A constant is a value that does not change, i.e., 2 or pi. A numerical expression may contain constants and/or operations. An algebraic expression may contain variables, constants, and/or operations. 4 operations. 1. Addition, plus, sum. 2. Subtraction, minus difference. 3. Multiplication, times, product. 4. Division, quotient. Subtraction undoes addition and division undoes multiplication. Adding and subtracting real numbers. Real numbers are the set of all numbers on a number line from negative infinity to infinity. Addition, move to right, i.e. plus 2. 2 units right. Subtraction is to the left. Note, subtraction is addition of negative. Absolute value is the distance to 0, i.e. absolute value of negative 2 equals absolute value of positive 2 equals 2. Opposite numbers add to equal 0, i.e. 2 and negative 2 are opposites because 2 plus negative 2 equals 0. A number and its opposite are additive inverses. Multiplying and dividing real numbers. Positive times positive equals positive. Negative times negative equals positive. If the signs of the factors are the same, the product is positive. A positive times a negative equals a negative. Division is multiplication of the reciprocal, i.e. 2 divided by 2 equals 2 times 1/2 because 1/2 is the reciprocal of 2. Two numbers are reciprocals if their product is equal to 1, i.e. 2 times 1/2 equals 1, so 2 and 1/2 are reciprocals. Multiplicative inverses are a number and its reciprocal. Inverse property of multiplication. A number times its multiplicative inverse equals 1. Properties of 0. Any real number a times 0 equals 0. 0 divided by any real number a equals 0. Any real number divided by 0 is undefined. Powers and exponents. A power is an expression written with an exponent and a base, i.e. 3 to the second power. 3 is the base and 2 is the exponent. Exponent tells how many times the base is multiplied by itself. The second power is sometimes called squared because it representing the area of a square with length equal to the base, i.e. 5 squared equals 25, which is the area of a 5 by 5 square. Third power is sometimes called cubed because it represents the volume of a cube with side length equal to the base. Roots and real numbers. A number that is multiplied by itself to form a product is a square root of the product. The opposite of the number is also a square root of the product, i.e. x times x equals x squared. So the square root of x squared is x. Negative x is also a square root of x squared. Plus or minus square root of x squared represents both the positive and negative square root. Positive real numbers have 2 square roots. The positive square root is called the principal square root and the opposite of the principal square root is the other square root. A perfect square is a number whose square root is a whole number. Some perfect squares are 1, 4, 9, 16, 25, and 36, which are 1 squared, 2 squared, 3 squared, etc. A number that is raised to the third power is the cube root of the cube product, i.e. the cube root of 2 cubed, or 8 is equal to 2. Only one real cube root, i.e. 2 cubed does not equal negative 2 cubed. Rational numbers are numbers that can expressed as a ratio of integers. A terminating decimal has a finite number of digits. A repeating decimal has a block of numbers that repeats. Irrational numbers cannot be expressed as a ratio of integers. Real numbers are all rational and irrational numbers. Order of operations. PEMDAS. Parentheses first. Exponents seconds. Then multiplication or division from left to right. Then addition or subtraction from left to right. Simplifying expressions. Commutative property. A plus B equals B plus A and A times B equals B times A. Order does not matter. Associative property. A plus B plus C equals B plus C plus A and A times B times C equals B times C times A. Grouping does not matter. Distributive property. A times the sum of B and C equals A times B plus A times C. The A gets distributed to both terms. Terms of an expression are the parts that are being added or subtracted. Like terms have the same variable. A coefficient is the number that is being multiplied by variable, i.e. term is 2x. X is the variable and 2 is the coefficient. Introduction to functions. A coordinate plane is formed by the intersection of 2 perpendicular axes, the x-axis and the y-axis. 4 quadrants and ordered pair, xy, describes a location on the coordinate plane. A function is a rule that assigns exactly one y value to each x value. Y depends on x. X is the input and y is the output. Y equals function of x denoted f of x. Solving equations by adding and subtracting. An equation is a mathematical statement that two things are equal, i.e. 2 plus x equals 0. A solution to an equation makes it true. To solve an equation, isolate variable using inverse operations. Subtraction undoes addition and addition undoes subtraction. A number c can be added or subtracted to or from each side of an equation, resulting in an equivalent equation. Solving equations by multiplying and dividing. Both sides of an equation can be multiplied or divided by a number c, resulting in an equivalent equation. Solving equations with variables on both sides. Combine like terms, then reverse parentheses to solve for isolate variable. Solving for a variable. A formula is an equation that states a rule for a relationship, i.e. the area of a circle formula is area equals pi times radius squared. Use inverse operations to solve for other variables. Solving absolute value equations. The equation absolute value of x equals a has two solutions. X equals a and x equals negative a. To solve the equation absolute value of expression equals a has two cases. Expression equals a or expression equals negative a. Rates, ratios, and proportions. A ratio is a comparison of two numbers by division, i.e. 2 divided by 3 or ratio of 2 to 3. A proportion is a statement that two ratios are equivalent. A rate is a ratio of two numbers with different units, i.e. 25 miles per gallon. Unit rate if the denominator is equal to 1. Cross products of a proportion are equal. Cross products are formed by multiplying the numerator of one ratio by the denominator of the other, forming two cross products, which are equal to each other. A divided by B equals C divided by D has cross products A times D and B times C that are equal. Dimensional analysis is a process that uses rates to convert units by using conversion factors. Conversion factors are equal to 1, i.e., 1 foot divided by 12 inches. A scale is a ratio between two sets of measurements, i.e., 1 inch to 5 miles. Scale drawing or model uses scale to represent an object as smaller or larger than it actually is, i.e., a map. Applications of proportions. Similar figures have the same shape, maybe not the same size. Two figures are similar if and only if corresponding sides are proportional and corresponding angles are equal. Indirect measurement is a method of determining the side lengths of similar figures using proportions. The scale factor between two similar figures A and B is the side of A divided by the corresponding side of B. Each pair of side and corresponding side share the same scale factor. Percents. A percent is a ratio that compares a number to 100, i.e., 2% equals 2 divided by 100. Applications of percents. Interest is the amount of money charged or earned from borrowing or investing. Principal is the amount borrowed or invested. Simple interest paid annually I equals PRT, where R is the rate expressed as a decimal. P is the principal amount and T is the number of years. Tip is an amount added to a bill, usually some percent of the bill. Tax is a percent of the cost. To find 10% of a number, move the decimal place one spot left. To find 1% of a number, move the decimal 2 spots left. Percent increase and decrease. Percent change is the increase or decrease given as a percent of the original number. Percent change equals amount increase or decrease divided by the original amount times 100%. A markup is an amount increase. A discount is an amount decrease. Graphing and writing inequalities. An inequality is a statement that two quantities are not equal, either less than or equal to, greater than or equal to, and not equal. Solution of inequality is any value that makes it true. To graph inequality, shade the solutions. Open circle on endpoint if endpoint value is not included in solution. Closed circle if value is included in solution, i.e., for less than or equal to. The equal to includes the endpoint in the solution. Solving inequalities by adding and subtracting. A number C can be added to or subtracted from both sides of an inequality, resulting in an equivalent inequality. A plus C is greater than B plus C is equivalent to A is greater than B. True for subtraction 2, and true for less than or equal to or greater than or equal to also. Solving inequalities by multiplying and dividing. Both sides of an inequality can be multiplied or divided by a positive number C, resulting in an equivalent inequality. If C is negative, the sign of inequality must be flipped. Solving two-step and multi-step inequalities. Use inverse operations to undo operation to isolate the variable. Solving inequalities with variables on both sides. Combine like terms and use inverse operations to undo operations and solve for the variable. Solving compound inequalities. A compound inequality is a combination of two or more simple inequalities with and or. The intersection is the overlapping region. Numbers in the intersection satisfy both inequalities. A union is a combination of multiple regions. Solving absolute value inequalities. Absolute value problems have two sets of solutions. If the quantity that the absolute value is being taken of is positive and if it is negative, i.e., the absolute value of x is greater than 2 has two sets of solutions. X is greater than 2 and if negative x is greater than 2. Graphing relationships. A continuous graph has n9 discontinuities or breaks in the graph. A discrete graph is only certain points. A graph can be increasing, constant decreasing, vertical, or horizontal. Relations and functions. A relation is a set of ordered pairs. The domain of a relation is the set of x values, or independent variables. The range is the set of the y values or the dependent variables. A function is a relation that pairs each domain value with exactly one range value. Vertical line test. No vertical line can intersect a function more than once. Each x value has only one corresponding y value. Writing functions. The independent variable is the input of the function, generally the x value. The dependent variable is the output of the function, generally the y value. Function notation. F of x equals y. A function rule defines a relationship between x and y. Graphing functions. Inputting x values into functions outputs y values. X and y together form ordered pairs of the function x, y. The ordered pairs can be graphed on a coordinate plane. Scatter plots and trend lines. A scatter plot is a graph with points plotted to show possible relationship. Can have a strong positive correlation, a weak positive correlation, a strong negative correlation, no correlation. A trend line is a line drawn to estimate the trend. Arithmetic sequences. A sequence is a list of numbers that may form a pattern, but does not have to. A term of a sequence is each number of the sequence. An arithmetic sequence is a sequence where the terms differ by a common difference. D. The nth term of an arithmetic sequence. An equals the previous term. An minus 1 plus d, which equals the first term of the sequence a1 plus d times the difference n minus 1. Using intercepts. Y-intercept. 0. Y is a point where the graph intersects the y-axis, which is the line x equals 0. The x-intercept. X. 0 is a point where graph intersects the x-axis, which is the line y equals 0. Rate of change and slope. A rate of change is a ratio that compares the amount of change in a dependent variable to an independent variable, i.e., change in y divided by change in x. Slope of a line. M equals change in y divided by change in x. Positive slope, negative slope, zero slope, undefined slope. The slope formula, given 2 points, x1, y1, and x2, y2. Slope of line through these 2 points equals y2 minus y1 divided by x2 minus x1, which equals change in y divided by change in x. The midpoint and distance formulas. The midpoint of segment AB has x coordinate of the average of the 2x coordinates, x1 plus x2 divided by 2. Same with y. y1 plus y2 divided by 2. The distance between 2 points A and B equals the square root of the sum of the square of the change in x and the square of the change in y. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. Comes form the Pythagorean theorem. A squared plus b squared equals c squared. Direct variation. Direct variation is a special type of linear relationship. Can be written as y equals k times x, which is a line with slope k and point 0, 0, comma k is the constant of variation. Slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept. Point-slope form. Given a point, x1, y1, and slope m. Equation of line is y minus y1 equals m times x minus x1. Slopes of parallel and perpendicular lines. Parallel lines do not intersect, do not share any points, and they have the same slope. Perpendicular lines intersect at a 90-degree angle. They have slopes that when multiplied together have product of -1. Transforming linear functions. A family of functions is a set of functions with graphs that share characteristics. The parent function is the most basic function of the family, i.e., f of x equals x is the parent of the line family. A transformation is a change in position or size. 3 types of transformations: a translation, or a slide, a rotation or a turn, and a reflection, or a flip. If a line is translated up, the y-intercept b increases. If translated down, b decreases. Changing the slope of a line results in a rotation about the y-intercept point 0, b, multiplying slope by -1 results in a reflection about the y-axis. Solving systems by graphing. A system of linear equations is a set of 2 or more linear equations containing 2 or more variables. Point where lines intersect is the solution of system of equations. Solving systems by substitution. Solve for a variable in one equation and substitute what this variable is equal to into the other equation for the variable to eliminate the variable. Solving systems by elimination. Eliminate variable by combining equations. May need to multiply an equation by a factor to evenly cancel. Solving special systems. A consistent system is a system with at least one solution. A system with infinitely many solutions is a system of equations of the same line. An inconsistent system is a system that has no solution. A system of equations of parallel lines is inconsistent. An independent system is one that has exactly one solution. Intersecting lines. A dependent system is one that has infinitely many solutions. Same line. Solving linear inequalities. Solution to an inequality makes it true. The solution is shaded. If point on one side of equation is included in the solution set, that side of the line should be shaded. If it is not a solution, the other side should be shaded. Solid line of the points along the line are included in the solution. For greater than or equal to or less than or equal to. Dotted line if not included. For less than or greater than. Solving systems of linear inequalities. Solve each inequality independently. Shade accordingly. The overlapping region of the solution regions is the solution to the system. These values makes all of the inequalities true. Integer exponents. 0 exponent. Any non-zero number raised to the 0th power equals 1. Negative exponent. A non-zero number raised to the negative nth power equals 1 divided by the number raised to the nth power, and 1 divided by the number raised to the negative nth power equals the number raised to the nth power. Powers of 10 in scientific notation. 10 to the power of 2 equals 100. 10 to the power of 1 equals 10. 10 to the power of 0 equals 1. 10 to the power of -1 equals 1 divided by 10. 10 to the power of -2 equals 1 divided by 100. Each exponent increase corresponds to multiplying by 10, and each exponential decrease corresponds to dividing by 10. Scientific notation. Method of writing large or small numbers with powers of 10. Multiplication properties of exponents. Rules of a simplified expression. No negative exponents. All powers raised to powers. All quotients and products simplified. No quotient or product raised to a power. Same bases multiplied or divided if possible. Product of powers property. When multiplying two powers with same base, add exponents. Keep base. Power of a power property. A base raised to a power equals the base raised to the product of the powers. Division properties of exponents. Quotient of powers property. If two powers with the same base are divided, subtract the exponents. Keep the base. Power of a quotient property. When raising a quotient to an exponent, raise both the numerator and the denominator to the exponent. Rational exponents. Index n and radical. Represents nth root. The nth root of a equals a to the power of 1 divided by a. A to the quotient of m divided by n equals the nth root of a to the power of m. For the mth root of x to the n. If m is even, the radical is positive even if x is negative. If m is odd, the radical is positive if x to the n is positive and the radical is negative if x to the n is negative. Polynomials. A monomial is a number, variable, or product of the two with whole number exponents. The degree of a monomial is the sum of the exponents of the variables. Constants have a zero exponent variable. A polynomial is a monomial or a sum or difference of monomials. The degree of a polynomial is the degree of the monomial with highest degree. The standard form of a polynomial has the terms in order of degree from highest to lowest. Naming polynomials. By degree. 0 is constant. 1 is linear. 2 is quadratic, etc. By number of terms. 1 is mono. 2 is bino, etc. Adding and subtracting polynomials. Identify like terms and combine them. Like terms have the same variable and the same degree. Multiplying polynomials. Multiply each term of each polynomial by each term of the other polynomial. Distribute each term. Then combine like terms. Special products of binomials. A perfect square trinomial is the result of squaring a binomial. A plus b squared equals a squared plus 2ab plus b squared. Difference of 2 squared. A squared minus b squared equals a plus b times a minus b. Factors and greatest common factors. A prime number is a whole number with exactly two positive factors, itself and 1, i.e., 2, 3, 5, not 4. 4 is not prime. The prime factorization of a number is the number written as a product of prime numbers. A greatest common factor is the greatest factor shared by two whole numbers, i.e., greatest common factor of 8 and 4 is 4. Factoring by greatest common factor. Use distributive property to factor out greatest common factor. If greatest common factor is equal to 1, cannot be factored more. Factoring special products. Perfect square trinomial factors to square of a plus b or to square of a minus b. Difference of two squares. A squared minus b squared factors to a plus b times a minus b. Choosing a factoring method. Check for greatest common factor. Check for special products. Check for common factors. Identifying quadratic functions. A quadratic function is a second-degree polynomial and can be written in form ax squared plus bx plus c where a is not equal to 0. The graph of a quadratic function is a parabola that opens up if a is positive and down if a is negative. The vertex of a parabola is the highest or lowest point of the parabola. Is the minimum value of parabola opens up and maximum value of it opens down. Vertex is at x equals negative b divided by 2a. The y value is f of this x. Characteristics of quadratic functions. A zero of a function is an x value that makes the function equal 0. A quadratic function may have 2, 1, or 0 real zeros. If c is greater than 0, there is no 0. If c is less than 0, 2 zeros. If c equals 0, 1 0. Axis of symmetry is the line x equals negative b divided by 2a. The graph is symmetric about this axis. Graphing quadratic functions. Find the axis of symmetry. Then find the vertex. Then find y-intercepts by setting x equal to 0. Then find value of point to left or right of the axis of symmetry and reflect it about axis of symmetry to find another point. Transforming quadratic functions. Parent function f of x equals x squared. Axis of symmetry at x equals 0. Vertex at 0, 0, 1 0 at x equals 0. Width of a parabola. F of x equals a times x squared is narrower than the parent function if the absolute value of a is greater than 1. Is wider if absolute value of a is less than 1. Vertical translations of a parabola. F of x equals x squared plus c is the parent function translated c units up if c is positive and down if c is negative. Solving quadratic equations by factoring. Zero product property. If x squared equals a and a is positive, then x equals plus or minus square root of a which equals a and negative a. Completing the square. Add the square of half of b to x squared plus bx to complete the square of x plus half of b. The quadratic formula and the discriminant. The solutions of quadratic equation ax squared plus bx plus c equals 0 are x equals negative b plus or minus square root of b squared minus 4ac. All divided by 2a. The discriminant is the quantity that the square root is being taken of. B squared minus 4ac. If discriminant is positive, 2 real zeros. If it is 0, 1 0. And if it is negative, there are no real zeros. Organizing and displaying data. A bar graph displays data with bars. Is easy to compare the values of a to b to c to d. A line graph displays data using line segments. A circle graph shows parts of a whole. Frequency and histograms. Stem and leaf plot arranged numbers by parts. Stem is tens place and leaf is ones place. The frequency of a valley is the number of times it occurs. A frequency table shows the frequencies of each value. A histogram is a bar graph used to display frequency of data divided into equal intervals. The cumulative frequency is the combined frequency of all values less than or equal to a given value. Data distributions. The mean of a set of numbers is the average of the numbers. Is the sum of the numbers divided by the number of numbers. Median is the middle value when arranged in order. If two middle values is the average of the two middle values. Mode is the value that occurs most often. Can have 0, 1, 2, or multiple modes. The range is the difference between the largest number and the smallest number. An outlier is a value that is very different from the other values. Quartiles divide the data into 4 parts. The second quartile is the median of the entire data set. Splits data in half. The first quartile is the median of the lower half. Splits lower half in half. The third quartile is the median of the upper half. Splits upper half in half. Creating 4 parts. The interquartile range or IQR is the difference between the third quartile and the first quartile. It represents the range of the middle half of the data. A box and whiskers plot is used to show how the values are distributed by using quartiles. Experimental probability. An experiment is an activity involving chance. A trial is a repetition or observation of an experiment. An outcome is a possible result of a trial. A sample space is the set of all possible outcomes. An event is an outcome or set of outcomes in an experiment. A probability is a measure of how likely an event is to occur, expressed as a percent between 0 and 100 or a decimal between 0.00 and 1.00. Experimental probability equals the number of times the event occurs divided h the number of trials. Theoretical probability. Same chance means the events are equally likely to occur. Theoretical probability equals number of ways event can occur divided by total number of equally likely outcomes. The probability of an event happening plus the probability of an event not happening equals 1. Complement events have sum of probabilities equal to 1. Odds in favor equals number of ways even can happen divided by number of ways event cannot happen. Odds against equals numbers of ways event cannot happen divided by number of ways event can happen. Independent and dependent events. An independent event is one where the probability of an event happening is not affected by the occurrence of another event. A dependent event is one that has a probability of occurring that is affected by the occurrence of another event. Probability of independent events. Probability of A and B equals probability of A times probability of B. Combinations and permutations. Fundamental counting principle. If there are m ways to choose first item and n ways to choose second item, there are m times n ways to choose combination of 2 items. A compound event consists of 2 or more simple events. A combination is a grouping of outcomes in which order does not matter. The combination of r things chosen from a group of n equals n factorial divided by r factorial times the difference n minus r factorial. Factorial i.e. 3 factorial equals 3 times 2 times 1 and 5 factorial equals 5 times 4 times 3 times 2 times 1, etc. A permutation is a grouping of outcomes in which order does matter. A permutation of r things chosen from a group of n equals n factorial divided by the difference of n minus r factorial. Geometric sequences. A geometric sequence is sequence where the ratio between numbers is the same. The nth term of a geometric sequence with ratio r equals the previous term times the ratio r, which equals the first term times r raised to the power of the difference n minus 1. Exponential functions. An exponential function has the form f of x equals a times b to the power of x, where a is not equal to 0 and b is not equal to 1 and he is positive. Exponential growth and decay. Exponential growth. Quantity increases by rate r every t amount of time. Exponential decay. Quantity decreases by rate r every t amount of time. Compound interest. A equals per times the sum 1 plus r divided by n raised to the power of nt, where p is the principal, a is the balance after t years, and r is the rate as a decimal. Linear, quadratic, and exponential models. Linear y equals mx plus b. Quadratic y equals ax squared plus bx plus c. Exponential y equals ab to the power of x. Square root functions. A square root function contains variable under square root, i.e., f of x equals square root of x. Radical expressions. A radical expression contains a radical sign. The radical is the expression under the radical. It may contain numbers, variables, or both. Simplest form of a square root expression. No perfect squared under radical. No fractions under radical. No square roots in denominator. Product property of square roots. The square root of a product a times b equals the square root of a times the square root of b. Quotient property of square roots. The square root of a quotient a divided by b equals square root of a divided by square root of b. Adding and subtracting radical expressions. Like radicals have the same radicand, i.e., 2 square root of x and 3 square root of x are like radicals because x is x. Like radicals can be combined by adding and subtracting, keeping the radicand the same, i.e., 2 square root x plus 3 square root x equals 5 square root x. Multiplying and dividing radical expressions. Use product and quotient properties of square roots, i.e., the square root of a times the square root of b equals the square root of the product ab. Solving radical equations. Power property of equality. If a equals b, then a squared equals b squared. Squaring both sides of an equation results in an equivalent equation. Inverse variation. Inverse variation is a relationship that can be written in the form y equals k divided by x. Y varies inversely, as x. K is the constant of proportionality. Product rule for inverse variation. If 2 points x1 y1 and x2 y2 are solutions of the equation y equals kx, then x1 times y1 equals x2 times y2, because k equals k and k equals x times y. Rational functions. A rational function is a quotient of two polynomial functions. An excluded value is an x value that makes the function undefined. A discontinuous functions have graphs that contain excluded values or discontinuities in the graph. A horizontal asymptote is a line that the function approaches as x becomes infinitely large in the positive or negative direction. For rational functions, there are vertical asymptotes at x equals a, where a is the excluded values. Graphs of rational functions approach, but never touch asymptotes. Identifying asymptotes. Y equals a divided by the difference x minus b plus c has a vertical asymptote at x equals b. This is an excluded values because any number divided by 0 is undefined, and a horizontal asymptotes at y equals c. Families of functions. Linear. Y equals mx plus b. Quadratic. Y equals ax squared plus bx plus c. Square root. Y equals square root of x minus a plus b. Rational. Y equals a divided by x minus b plus c. Simplifying rational expressions. Find excluded values. Exclude those and then simplify quotient if possible, i.e., 2x divided by x. X's cancel resulting in 2. Multiplying and dividing rational expressions. To multiply. Multiply the numerators to give numerator of product and multiply denominators to give denominator of product. A divided by b times c divided by d equals a times c divided by b times d. To divide. Flip the second expression's numerator and denominator and change the operation to multiplication, i.e., a over b divided by c over d equals a over b times d over c. Adding and subtracting rational expressions. The denominator must be the same. If they are the same, add or subtract the numerators and keep the same common denominator. May need to find common denominator by multiplying by the denominator of other. Then simplify if possible. Dividing polynomials. Factor numerator and denominator if possible. Then cancel common factors in both numerator and denominator, and simplify. Solving rational equations. Use cross products. Cross products of proportions are equal.